across the seven seas, under the protection of armed escort, men and weapons of the United Nations move out to far-flung battlefronts, carrying the fight to the strongholds of the enemy. And the ships get through. Busy docks near the scene of action. And case after case of American fighting planes, hard-hitting P-47 Thunderbolts. The job now is to hurl these Thunderbolts into action without delay. That requires the quick uncrating and assembly of the airplane under any conditions, anywhere. To make this possible, a simple, practical method of uncrating and assembly has been devised, by which the P-47, although it weighs nearly 7 tons, can be ready for battle without the aid of special equipment, such as heavy jacks, cranes, or hoists. To assemble a P-47 under field conditions, the only equipment needed is a standard set of mechanics tools, manpower, and the shipping cases themselves.
The first step in the whole procedure is for the crew chief to read the instructions that are fastened to the front end of either of the shipping cases. Important: do not remove shipping cases from trucks until after you have read these instructions. The instructions are simple but important. Each step must be carefully followed. The instruction book should be read completely so that the crew chief may have an overall picture of the job to be done. Then he can go to work. First, the truck bearing the wing case is drawn up behind the fuselage case. This provides an elevated surface on which the men can stand while removing the fuselage case top. The fuselage case must remain on the truck. The top of the fuselage case is removed in one piece. Take out the lag screws and pry up one end with a crowbar. This end is held up with a short piece of timber wedged into place. Two or three lag screws, which are inserted in each corner of the top, serve as towing posts, around which is looped a length of 1-inch rope. Now, with manpower, the top is dragged off the case onto the ground. After the lag screws have been removed from one of the sides, this panel can simply fall to the ground. And the other side is removed in the same way. Then, the ends of the case are taken off. We're going to need those stringers all through the job. They are pried loose from the sides of the case. They are sawed through the middle, and the two halves are nailed firmly together. Now we are ready to unload the wing case and remove its contents. For this job, you need a pair of skids and the 1-inch rope. Hey, go easy. That case weighs over 3 tons. When its top has been pulled off, the sides and ends of the wing case are removed by the same methods used on the fuselage case. After the hinge fittings in the wing case have been loosened, approximately 50 men, using the fuselage side stringer sections for lifting, carry the wings out of the case and place them on the ground. This wing is being turned over so that the landing gear is on the underside for convenience later on in assembly. After both wings have been taken out, the other parts in the wing case are removed. The parts from the wing case are laid out in orderly fashion, and the crew chief is now ready to direct the construction of the platform on which the plane will be assembled. This platform is built entirely out of the material that makes up the two shipping cases. The first essential is a plot of firm, flat, and level ground. On this is placed one of the sides from the fuselage case with the flat side up. 8 feet from the front of the platform and on each side, a slot is cut for wheel clearance needed later in assembly. This slot is 30 inches long and 6 inches deep. Now the second side is brought up and laid over the first. A similar slot is cut in this second side. The finished platform looks like this. And here it is in diagram. Let's see how it's built. Here are the two fuselage case sides nailed together to form the base of the platform. Now comes the end of the fuselage case and the top of the wing case. Then comes a side from the wing case. And on the same level, a fuselage end. The remaining wing case side and the two ends from the wing case are laid on top and nailed in place. This leaves a space toward the back of the platform, which is built up by nailing together 3 2x4s taken from the wing case stringers and laying them lengthwise like this. The top of the fuselage case becomes the top layer of the platform. A diagram similar to this is reproduced in the instruction manual and should be followed in detail when the platform is being constructed. At this point, the crew chief is ready to direct the transfer of the fuselage onto the platform. If the level of the trailer bearing the fuselage is higher than the platform you have built, wheel pits of sufficient depth should be dug to bring trailer and platform to very nearly the same level. The truck bearing the fuselage is slowly and carefully backed up. Keeping it always in exact line with the platform. The prime mover is disconnected. A tow line is fastened around the entire bottom of the fuselage case. And by using the prime mover, the bottom of the case with the fuselage itself is eased squarely off the trailer and onto the assembly platform. Steady. Steady there. Just a bit more. Pull it right to the edge. Okay. Now, exactly at the back end of the shipping brace, the 10-inch section of floorboard is removed from the fuselage case bottom. Then a 10-inch section is cut out of the exposed 4x6 beams on each side. These cutaway sections, like the slot in the base of the platform, are important later in assembly. It is also necessary that the rear members of the shipping brace be removed. These members have been bolted and lightly welded in place. The bolts are removed and the weld is broken. That concludes the construction work. The crew chief can now begin to direct the actual airplane assembly. First, the engine cowling is taken off. This goes quickly if at least 4 men are assigned to the job. Now the engine must be cleaned. Kerosene or other suitable solvent may be used in removing the anti-corrosion compound sprayed over the engine before shipment. The carburetor and lower cylinders should be drained of any oil or moisture which may have accumulated. Also, the spark plugs and connecting harness must be installed. These procedures should be done in accordance with instructions found in Technical Order number 02-1-1. While this is being done, the protective tape and other coverings are taken off to expose all openings and fittings of the fuselage, wings, and all other parts. After complete inspection of the work that has been done on the engine, the cowling may be replaced. During shipment, steel braces have supported the weight of the airplane. The braces are connected to these wing hinge or pin connections. The weight must be released and transferred to these steel resting pads. This is accomplished by turning up the jack screw just 2 or 3 turns. This is enough to relieve tension on the master bolt. Then, the master bolt, which has actually carried the full weight of the plane, can easily be removed. The direction of the jack screw is then reversed. It is turned down until the weight settles on the steel resting pads. Now the hinge bracket may be removed. The hinge is then free and clear, and ready to receive the wing. To prepare for the wing assembly, we remove the pilot's seat to provide more working space in the cockpit. Now, caution. Both aileron control rods must be inserted now, flush with the fuselage. It will be too late after the wing is on. The crew chief checks to be sure that all wing connection drift pins, bushings, bolts, and tools are ready and on hand. When he's sure that everything is in its place, he can start to direct the actual wing assembly. It takes about 50 men to carry the wing of a Thunderbolt. Easy does it. That baby weighs over 1,800 pounds. The trick here is to line it up straight. Take it slow. Drop the wingtip just a little bit so that the bottom set of hinges can be lined up and connected first. After the lower set of hinges had been secured, the wingtip is lifted and the upper hinges are lined up. Both upper and lower wing and fuselage hinges are secured in the same manner. They are lined up with the aid of drift pins. When the hinges are in perfect alignment, the bushings are installed, always with the split side upward. A bushing inserter is used to drive the bushings through the hinges. The drift pin is forced out as the bushing is driven home. When all the bushings are in place, the men can ease off a few at a time so that the support they have been giving the wing will be released gradually. Next, the tapered bolts are inserted. The heads of these bolts should always be facing each other, pointing toward the inside of the wings. Tap and tighten, very carefully. Finally, the bolt is brought to correct tension with a 2-finger pull on an 8-inch wrench until at least 3 threads are visible on the end of the bolt. Once both wings are on, we are ready to make all wing root connections, except for the cables and control rods. This requires a thorough understanding of the connections to be made and their location. Since these connections are in very tight quarters, let's look at an animated diagram. Here are the connections to be made at the left wing root. The fuselage is here, and the wing root here. Here are the connections which are found in both wings. The flap hydraulic lines, the cannon plug, the aileron control rod, the landing gear and brake hydraulic lines, the uplock cables, and the gun heater tube. Now let's see the connections found only at the left wing root. They are the aileron trim tab cables, the static and pitot airspeed lines, and the oxygen line. Here's the situation on the right wing. In addition to the connections you see here, which are common to both wings, we have the fuel vent and the cockpit air scoop. Remember, at this point, we make all connections except the control rod and cable connections, which should not be made until after the landing gear is down. In preparation for lowering the landing gear, a pit must be dug under each wing in line with the path that the wheels will take. This pit will have a maximum depth of about 1 foot at the point where the gear is fully extended. To lower the gear, wires which were attached to the uplock cables for shipping purposes are pulled at the wing root. The gear will now extend. Here is the reason we cut out that section of the platform. It would have obstructed the passage of the wheel. Notice, too, that the pits are dug quite close to the platform. In order to bring the gear down to the full downlock position, it is necessary for 2 men to get behind and push. When the downlock position is reached, an audible click is heard. With the necessary access holes now available, the uplock cables, the aileron control rods, and in the left wing, the aileron trim tab cables can be connected. Let's see what goes on inside that wing he's reaching into. To connect the uplock cables, the ends of the cables from the fuselage are drawn into the wing. The short cable from the fuselage is connected to the long cable in the wing through this access hole. The long cable from the fuselage is connected to the short cable in the wing through this hole. These connections are made with the turnbuckles, which are drawn up to a tension of 25 to 30 pounds. On the back side of this spar is a micarta guide block, which we see here. The cables are threaded through this block. Now, the aileron control rods. There's an access hole in the cockpit floor here. By reaching down through this hole, we can secure the rod with this bolt, washer, and elastic stop nut. In the wing, the same procedure is followed by reaching up through the access hole and making the bolt, washer, and nut connection. Here we see a closer view of both connections. the fuselage connection, and the wing connection. The trim tab cables remain to be connected. Here is the left wing. Here are the cables running out through the wing. By reaching down through this access hole in the top of the wing, connection is made by means of a turnbuckle. Tracer wires attached to the ends of the cables aid in pulling the cables to the points of connection. The long cable, pulled through by tracer wire, is connected to the chain by reaching up through this access hole. At this opening, reach in and install the pulley guard with a clevis pin and cotter pin provided. Here is a closer view of the pulley guard, showing where the clevis pin is inserted. A safety wire, which has been fastened around the chain, is now removed, and the cable tension is adjusted to 35 pounds. With all wing connections now complete, the next step is to make preparations for checking out the operation of the landing gear. First, we check the fluid in the hydraulic reservoir. Pressure is then built up in the hydraulic system by using the hand pump in the cockpit until the indicator shows 1,000 pounds. The flaps and brakes are now bled according to standard technical orders. 90 pounds pressure is pumped into the upper chambers of the shock struts, putting the gauge on the valve to the lower chambers. Next, after making certain that all the switches in the cockpit are in the off position, the battery, which should be brought up to full charge, is installed. Then the crew chief is ready to direct the actual testing of the landing gear, which should be raised and lowered at least 3 times. In the first retraction of the gear, the crew chief should check to see that the inner door and strut fairings fit smoothly in the wing. The next complete operation to be checked is that of the landing gear warning light. This light should remain on while the gear is being extended and should go out when and only when the gear has reached the full downlock position. The third testing of the gear is made for the purpose of checking the operation of the transfer valve. The rear inflation valve is removed, the gauge is put on the front inflation valve, a pump is attached to the gauge, and 90 pounds pressure is pumped through the gauge into the lower chamber. The gear is retracted to the point where pressure is seen to drop in the gauge. That's enough. Then a bevel protractor is applied to the gear. If the gear is 6 degrees from vertical, or within a minimum of 5 degrees to a maximum of 10 degrees, the transfer valve is operating correctly. We can get ready now to roll the plane off the platform. To do that, we must transfer the weight of the plane from the platform to the landing gear. First, the air must be released from the lower chambers of the shock struts. The landing gear must be fully compressed and held in this position while the pits are almost completely filled in and the earth packed hard under the wheels. Now the man in the cockpit should park the brakes. The entire plane is then jacked up by pumping air into the lower chambers of the shock struts. To make the pumping job easier and to relieve strain on the pump, several men rock the plane by pushing up on the wing. The result is that the plane is lifted above the steel rest pads of the shipping brace. Once the weight of the plane has been transferred to the landing gear, the two center skids behind the shipping case bracket are sawed through, and the front section of the fuselage platform with the supporting irons is pulled forward and clear. Now we are ready to release the tail from its shipping case brace. In preparation for this, air is pumped into the tail wheel strut until the piston is completely extended. The man in the cockpit locks the tail wheel to prevent it from turning sideways. We must build a track for the tail wheel to run on. To do this, we make use of one of the stringer sections formerly used to carry the wing. It is sawed into 3 equal lengths and laid directly under the tail wheel in the manner shown here. The other stringer section is placed under the empennage jack pad. 8 men now lift the tail slightly to ease the tension on the tail shipping brace bolt. When the bolt is removed, the tail is slowly lowered until the wheel rests on the tail track. The stringer we just used to lift the tail can now be sawed through the middle, and the 2 sections placed in front of the platform to form a tail wheel ramp. The tow lines are made ready and fastened to the towing hole. Stop, not there. That's the uplock hook. Use the hole that's marked for towing. A jeep is mighty handy in pulling the plane away from the platform, but manpower can do the job if necessary. The short sections of tail track are moved progressively as the tail wheel rolls forward. During this roll-away operation, the man in the cockpit keeps a slight tension on the brakes to ensure slow, even movement of the plane. Here she comes down the ramp, looking more like a P-47 every minute. Now is the time for pre-flight adjustments and inspections of the landing gear shock struts. First, all of the air is released from the lower chambers to allow the strut pistons to be fully bottomed. Next, we remove the plug on the lower chamber to see if it contains the proper amount of fluid. If there is sufficient fluid in the cylinder, it will be found level with the plug opening. Now the strut chambers are checked for proper pressures. 90 pounds is correct for the upper, and 360 pounds for the lower chambers. With these pressures, the clearance between the bottoms of the lower chambers and the ends of the pistons should be 1 5/8 inches. To make certain that there has been no leakage in the transfer valve, the gauge is put on the upper chamber and checked again to see if it reads 90 pounds. We're moving right along now, and we're ready for installation of the tail feathers. The fin and horizontal stabilizer are treated as a subassembly, which is installed by means of 10 bolts here and here, and 4 bolts in the rear bulkhead here and here. When this is done, the crew will be ready to string the control surface cables. There can be no confusion in stringing these cables because before shipping, each cable has been tagged to show where it goes. After the cables have been strung, the pulleys are put in place. The elevator tab cables are connected, and the cover plates are put on. The same procedure is followed for the rudder trim tab cables. Now the trim box in the cockpit should be set in neutral. The elevator control rod is placed in the tail and into position. The forward end is connected inside the fuselage. The elevator can now be installed. On each side, there are 2 stabilizer hinge fittings and 1 trim tab universal connection. The elevator control rod is connected to the elevator. The rudder is connected at the 2 pin hinges here and the rudder trim tab universal here. The rudder cables are connected next. This can be done only after the man in the cockpit has put the control lock to on position in order to place the rudder in neutral. When all the cables, bonding, and rudder tail light have been properly connected and inspected by the crew chief, the assembly of the tail feathers is complete. The ship is now ready for the installation of the propeller. Here are the steps in preparing for propeller installation. The plane is nosed up to within about 2 feet of the platform, so the men will have something to stand on while they work. Your very first action is to remove this brush holder assembly, because the brushes would be snapped off if the propeller were put on with the brush holder in place. Out comes the inner cone. And don't forget the shim, which is right behind it. The cone and shim must be thoroughly cleaned with a suitable solvent, and also the propeller shaft. The splines on the propeller shaft and also the cone and shim are then coated with a light oil. When this is done, the shim first and then the cone are replaced, making sure that the open portion of the cone is at the top. The propeller lock nut threads are coated with the prescribed mixture of castor oil and white lead. While the shaft is being made ready, the protective coating from the propeller itself can be removed. The splines on the inside of the propeller hub are cleaned and oiled, and the slip rings are wiped clean of any oil or dirt. When both the shaft and the propeller are ready for assembly, the propeller is brought up to the plane. You need at least 10 men for this job. Under the guidance of the crew chief, the propeller is carefully placed on the shaft. The number 1 blade should be on top so that the splines will be readily engaged. Now the main propeller shaft nut is tightened with the 4-foot propeller bar. After the nut has been drawn tight, insert the locking sleeve and secure with the lock pin assembly. Next, after cleaning, the brush assembly is put in place and the brushes checked for proper clearance on the slip rings using Prussian blue according to standard procedure. The propeller hub electric contact points are cleaned and made ready to receive the power unit. The power unit itself is removed from the case and cleaned with particular attention to cleaning around the contact points. Since the power unit is set in low pitch when packed, the blades on the propeller must be set in low pitch also. When the power unit is installed, the 8 bolts are drawn up and secured with safety wire. The propeller gear housing is then greased, and the speed-reducing gear housing is oiled. With the power unit cover or spinner installed, the propeller assembly is complete. Now, all of the major connections on the airplane have been made. After a thorough inspection by the crew chief, we install the fillets and secondary cowling. The pilot's seat is returned to its place in the cockpit. And when the pitot tube, antenna wires, radio mast, and pilot's rear view mirror have been installed, the armorers are ready to take over, to install the guns and charge them. The job of assembly is done. The plane is towed off to the airfield runway. Here, after the plane has been fueled, the crew chief runs up the engine and makes one final check on the operation of all instruments and movable surfaces.
Ready to fly and ready to fight. This plane has been completely uncrated and assembled in the field. This simplified uncrating and assembly method is the answer to field requirements. Just as the plane itself, the P-47, answers the requirements of the fighting pilot. The Thunderbolt is in the air.